Alright, this is the review for the expressions unit. So let's start with number 1, part A. Give an example of a rational times a rational that has a rational solution. Well, we know that a rational number is any number that can be written as a fraction. So all we really have to do is find any number that's a fraction, multiply it by any other number that's a fraction, and show that we still get a fraction. So I'm going to pick something like 3 over 2, and I'm going to multiply it by 4/3. That a little bit better, 4/3. And if I multiply those together, I'm going to get 12/6, which is just the number 2. So I have a rational number, and I get a rational number. So this is always, sometimes, or never true. It's going to be always true. And we wrote that in our little flip chart. We can say because we always know what the value is, would be a good enough explanation. Meaning, I know what the value of 3/2 is, I know what the value of 4/3 is, and I know what the solution is. Give an example of an irrational times an irrational that has an irrational solution. So this time I want something that I don't know, like a square root or pi, multiplied by something else I don't know, and get something that I still don't know. So that could be like pi times the square root of 2. I don't know either of those things. Pi is about 3.14. Radical 2 is 1 point something. When I put them together, I just get pi square root of 2, which is still irrational. And for this one, we can say that it is sometimes true, and the reason would be if I had the square root of 2 times the square root of 2, I'm going to get the square root of 4, which is just 2. So in this case, this is a counterexample. In this case, it says that we have an irrational times an irrational, but we get a rational result. So let's move on to number 2. The triangle has a regional area of 20 feet. What possible combinations of irrational rational for the base and height would give a rational value of the area? So we need to think of rational and irrational numbers that give a rational answer. So we could say we could say 1/2 times 3 times 4. That's going to be 6. So we have all rationals, which gives us a rational. We could have all irrationals, which gives me 2, which is still rational. And let's see, what else could we have? Could we have an example of a rational with an irrational? That's going to be no. But I could have some other irrational numbers. I could have like the square root of 2 times the square root of 8. 2 times 8 is 16, which just gives me the square root of 16, which is 4 times 2, which still gives me 2. And actually, so I messed up this top one. That one should be 1. But those would be combinations of rational and irrational numbers that give me rational values. Okay. Number 3, given the triangle below, D is irrational. Explain why the perimeter is an irrational number. Okay, so if D is irrational, so if all of these are irrational, it means that this is irrational because you're adding a rational and irrational. This is irrational. And finally, this is irrational. So basically the rule is if we have 3 irrationals, added together, we get an irrational. All right. Number 4, given the expression 6xy plus 8, identify the coefficient. Remember, the coefficient is the number attached to a variable, so that would be 6. Given the expression, identify the constant. The constant is the term without a variable, so that would be 2. Identify the factor of x. So remember, we have an x squared term and we have an x term. Okay, the factor of x, or the factors of x, are going to be 3 and x. Those are the two factors. And this one, simplify the expression and then find the terms and constants. So first we're going to start by distributing to all 4 terms. So we get 3x plus 4xy minus 27y plus 6. There is one constant, which is the 6. And the number of terms, we have 1, 2, 3, 4 terms. Alright, number 5. Moving company charges $880 plus $16 per hour. The expression. So we get charged $880 plus an additional $16 for every hour that we have it. So H is hours. The factor would be the parts that have like a coefficient and a variable, so that would be the 16h. So my factors are the 16 and the h. Number 6, evaluate the algebraic expression. So remember, we have to plug in for a and b. So it's going to be negative 4 times 3 plus negative 2 squared. Order of operations, we do inside the parentheses first. So it's negative 4 times 1 squared. Now we can do exponents. 1 to the second power is just 1. So you get negative 4 times 1, which is negative 4. Number 7, interpreting parts of expressions. Explain whether negative 3y squared plus 6 will be positive or negative if y is positive. So we're going to say for this one that it is sometimes positive. And it's sometimes positive because this first term will always be negative. So if we pick a value for y, y has to be positive, but whatever value we pick, we're going to square it. So if we square it, that's positive. Then we multiply by negative 3, so we have a negative. So we've got a negative number and then a positive number. So what we can say is if negative 3y squared is larger than 6, we have a negative value. If negative 3y squared is smaller than 6, we have a positive value. So, for example, if y was positive 1, 1 squared is 1 times negative 3 gives me negative 3. Negative 3 plus 6 is positive 3. So that would be the second case. If y was 2, 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 6 is negative 6, which would be the top case. So we have one example of each. Part B, explain whether negative 3y plus 6 will be positive or negative if y is positive. Well, that's going to be the same thing, really, because if y is positive, then this term, negative 3y, will be negative, and then it depends on the size. Of the two terms. So again, if negative 3y is greater than 6, we'll have a negative value. If negative 3y is less than 6, we'll have a positive value. Part C, explain whether x plus 3y squared will be positive or negative if x is positive. So if x is positive, this will be positive. And y is squared, so this term will also be positive. So since both terms are always positive, my solution will be always positive. And justify your claim. Since x and 3y squared are always positive. I should have said since, should have said because. Alright. Number 8. Sam writes two algebraic expressions using each of the variables x and y only once. The first expression she writes uses x and y as factors. Then she writes the second expression using x and y as terms. So remember, factors mean they're multiplied together, so that's x times y. And terms means they're added, x plus y. If x and y are both positive, write a comparison between the two expressions. So we have x, y, and we're comparing it to x plus y. And the comparison needs to be inequality symbols. So this one's a little tricky because there's a couple cases that could happen. You could say xy is generally going to be greater than x plus y, but there are a couple examples where it won't work. If x and y are both 1s, 1 times 1 is 1, but 1 plus 1 is 2, so x plus y would be greater. But if x was 2 and y was 3, 2 times 3 is 6, 2 plus 3 is 2 plus 3 is 5. Okay. And they're always going to be positive, so it depends on the size of x and y still. Part B, if x and y are both negative, write a comparison between the two expressions. So again, x, y. For this one, I'm going to actually write sometimes x times y compared to x plus y. So for this one is always greater. And the reason why, if x and y are both negative, a negative times a negative leaves me with a positive, but a negative plus a negative will always be negative, and a positive is always larger than a negative. Part C, if x is positive and y is negative, write a comparison between the two expressions. So x, y compared to x plus y. Again, this is going to be, it's going to depend on the size. So we can say that this is very similar to part A, where it depends on the size of x and y. We know that this value is always negative. This value is going to be positive or negative depending on which one is larger. So, and then from there we have to decide which one is greater. But if we're looking at the same sign of numbers, the x times y should be greater. But I'm going to leave that one without an inequality symbol. The comparison is just going to be the xy will sometimes be larger than x plus y. And the last problem. Hector downloads 27 songs from iTunes each month for m months in a row. Write an expression to show how many songs Hector downloads in all. So if he downloads 27 songs a month for m months, that's going to be 27m. And then part B, find the number of songs Hector downloaded in 2 years. Well, so 2 years needs to be converted to months. We know that there's 12 months in a year, so that's 24 months. So we're going to do 27 times 24. And 27 times 24 leaves us with 648 songs. So that's the end of our review. Good luck on the test. Make sure you ask questions in class tomorrow.